So hello everyone, we'll be getting started in just a minute. I'm just going to give everyone a moment to finish logging in and getting set up. Feel free to introduce yourself through the chat button in the black bar at the bottom of the screen so that our panelists know who is all in attendance. And again, we'll get started in just a minute. All right, so welcome everyone. Again, feel free to introduce yourself and your firm through the chat button at the bottom of the screen. This is Erin Donovan, Interim Director for the AIA New Orleans. Thank you all for joining us here today. Today we have a presentation from professional affiliate member Sherwin Williams. And a note up top about the format for the webinar today. So everyone will be on mute, but feel free to use your chat function or the Q&A function at the bottom of the screen to ask a question for the presenters. We are a small team, so we can't really troubleshoot for you over the course of this webinar. If you do run into issues with Zoom, you should feel free to call in using the backup phone number that you should have received this morning in your email. If you call in and you do want credit for attending the course, just please email your name and AIA number to lauren@aianeworleans.org to get credit for the session. On the agenda for today, we'll be hearing from Philip Smith on seamless wall and floor systems. We'll have a brief Q&A at the end, and then we'll close out with some upcoming events at the AIA. Our speaker, Philip Smith, after graduating with a bachelor's degree in urban development from the University of South Carolina, Philip Smith began his career in construction and real estate development. Today, Mr. Smith is part of the Specifier Services Group with the Sherwin-Williams Protective and Marine Division, assisting the design community with recommendations for resinous floor and wall coating specifications. He is a current member of CSI, SSPC, and a certified NACE Level 3 inspector. Mr. Smith travels the US lecturing to groups regularly and is certified through Sherwin-Williams as a provider of AIA continuing education seminars relating to resinous floor and wall coatings. All right, we'll turn it over to you, Philip.
Okay, thank you. Let's see, I am going to try to take over the screen. Okay, give me just a second. Okay, you seeing my screen? I'm going to assume you are.
Yes.
Okay, good. Okay, very good. Let me go to the next slide. Todd, you want to introduce yourself?
Sure, thanks, Philip. Yeah, so I'm Todd Hakenjos. I'm the A&D rep for Sherwin-Williams that covers the New Orleans area, actually office out of Metairie. So just wanted to introduce myself briefly before Philip takes over. I've been with the Sherwin-Williams company 25 years, pretty much all in the New Orleans area as well. And like Philip, my role with the company is to assist design teams with coating selections, specifications, color samples, those kind of things. And as many of you know, Sherwin-Williams, you probably know Sherwin-Williams can help with solutions for architectural and commercial wall coatings, ceiling coatings, those kind of things. Many of you probably don't know how much we can help with high performance resinous floors. So what I've done is ask Philip Smith, who's a tremendous resource for me to support you as a specifier or designer, to come in and talk about seamless walls and floor systems. So with that, I'll turn it back over to Philip, and I appreciate the opportunity to introduce myself.
Okay, y'all already said who I am, so you know that. I do cover the Southeast US and Caribbean. I've got about 20 plus years in this resinous flooring, and I would like to say this. Sherwin-Williams got into the resinous flooring business about 20 years ago. We acquired a company called General Polymers. If you've ever heard of General Polymers epoxy floor coatings or General Polymers terrazzo, that has been a product or a brand of Sherwin-Williams since the year 2000. We bought that company at that time for their resinous floor and wall coating business, and they were manufactured materials out of Cincinnati. We still have that factory today, and we distribute the products for the resinous flooring business out of designated stores. You can't just walk in any store and buy this stuff. Only certain stores carry it. It's kind of complicated material to install. We also only sell the General Polymers floor line, which we're actually rebranding that and it's coming up with a whole different name because we've carried the General Polymers product line all around the world now. We've been buying other companies in Europe, and so we've got a pretty good global presence with this resinous flooring business, but we try to only sell to approved applicators, people that have been trained and are skilled in installation of these resinous floor and wall systems and terrazzo, because again, it's pretty complicated. So that's kind of the backstory of how we got into this. And I want to talk today about how do you select one of these systems? How do you prepare the concrete surface to apply these materials onto? Installation strategies, kind of what works best to make sure that you get a good end result. And then I want to talk about some different technologies, especially new technologies, because things are ever changing and trying to be more environmentally friendly and lower VOC and achieve LEED credit. So let's just jump right in and talk about resinous flooring. See in the top left of your screen in red, you see the word resin-us, and that's exactly how we get the word resinous flooring. We take that can of A, which is your resin, and we mix it with that can of B, which is your hardener. And that's often referred to as two-part material or two-part paint. And that's what we mean. There's two parts mixed together. In the blue bucket, you see the 2B mixed together, and that's creating heat, like an exothermic reaction. It starts to chemically cure in the bucket. And then we have to pour it out on the floor or roll it out onto the floor in a timely manner so that it doesn't get sticky and gooey before we make it look pretty. And that time, that amount of time that you have is known as the pot life. How long is the pot life that you have? How long is the working pot life of the material? So in the top left, you'll also see the word polymer. So the reason it's often called polymer flooring is because once that blue material in the bucket cures, it's like a plastic. It literally is a plastic, a polymer. So you'll either hear these referred to as epoxy floors or resinous floors or polymer flooring. And they're all the same. We're saying really all the same thing, but technically they're a little different. Let's talk about when you do select one of these systems. The first thing we'll ask in the top right of your screen is cost. How much do you have assigned in the budget? And many times you don't even know the answer to that question, and that leaves us a little, we're not in a great spot to make a product recommendation, and here's why. The least expensive resinous floor coating system is about $3 per square foot installed. Okay, once you prepare the concrete, get it very clean and blasted, or you grind the concrete, and then you get it vacuumed and you tape it all off and you apply at least a prime coat and usually then at least a top coat, you're already into the $3 per square foot cost range. So that's kind of the entry point. So just know that your client needs at least about $3 a square foot in their budget to be able to afford one of these systems. And if they want to afford, a quality installation. And then we'll ask you other questions like safety. ESD in the top right, that stands for electrostatic dissipative. You ever touched a doorknob and you kind of shocked yourself like you sent off a spark? We've got coatings that we can apply onto the floor that actually absorb the static electricity out of your body so that you can't build up a charge. And that would be important in an area that had odorless, invisible, explosive gases where you didn't want to discharge and then blow up the room. That could be in chemical storage areas, fabric plants that store a lot of chemicals for their dye process, munitions, fireworks, any of those type areas you may want electrostatic dissipative or even conductive. We'll also ask you questions like what kind of resistance to certain things do you need, like thermal shock. Thermal shock by definition is instant heat that hits the surface that's 100 degrees hotter than the surface. So if you've got a 100-degree hot substance hotter than the floor, instantly hitting that floor, like say a commercial kitchen around a kitchen fryer, where you've got the hot oil spilling, that would be a thermal shock condition. Well, what about the cooler or the freezer in that commercial kitchen where you've got hot washdowns? You're definitely going to see thermal shock situations there. So we want to know about those because certain chemistries in our line of products absorb that heat and resist it better. Abrasion would be the next thing. We're pretty in tune with abrasion. That's scratching the floor. Are you going to push, pull, or drag objects across that floor? Say like a student hall where they're moving furniture into the building and they might just push it down the hall. Or what about a cafeteria where they're scooting away from the table and those chairs, the feet of those chairs all day long are scratching that floor? That's pretty heavy abrasion. So we've got additives like we can take fine baby powdered aluminum oxide and mix into that bucket. You won't even see that, okay? That aluminum oxide will be such fine little particles, but we'll roll it out and it will increase the scratch or abrasion resistance up to 6 times, okay? It'll make that coating really, really tough to scratch. It'll also make it tough to recoat. So that's a drawback, but the benefit is it's tough to scratch. If you do have to recoat it, you have to sand it pretty aggressively. The next thing we would ask is like impact. Are you dropping objects on the floor often, especially in the same repeated area? And an area that we would see like that would be like a tool room or mechanical room, or maybe a fire station where the guys are throwing all the gear off the truck, you know, routinely in the same spot over and over, and they would impact that floor, crack or chip that coating, or maybe just chip the concrete underneath the coating that eventually pops through the coating, and now you've got problems. Then we might ask you about chemicals, and it's not necessarily that this is a laboratory where you're using chemicals. What if it is like that commercial kitchen where they're using sanitizers just to clean and make a sanitary kitchen? Most often they would use bleach. That's like sodium hypochlorite. And then you've got other sanitizers. In today's, state of current affairs, sanitizing is pretty important. Animal shelters, veterinarian clinics, all your healthcare facilities are going to use sanitizers. So we want to know what kind, and those are going to be in the chemical classification. And then the last thing that's really important we want to know is moisture vapor. Do you have any concerns about it? Is there any moisture underneath that concrete or inside that concrete? Are you near a body of water like a river, a lake, an ocean? Is your project got any concerns about moisture? So as we dial in on making the recommendations, we might ask a few more things like, is the area sloped to the drain, or do you need it sloped to the drain? What kind of texture do you need? Because the more texture you have, the less risk of slipping and people falling, but the more difficult it is to clean that floor. So there's like a balance of, enough texture to create low slip fall hazards, but not too much texture so that you can clean the floor and mop it. It doesn't grab the cotton off the mop. And then odor, hey, is this area going to be occupied or other trades going to be adjacent during the application? And the good part is most of these materials, you can smell them, but they're not harmful. You don't have to wear respirators. Almost no VOCs in these products anymore. Very low, if any. There are some exclusions to that rule. And then repairability. We ask that question not because we think the floor coating is going to fail and you're going to have to patch it. We just want to know, are you going to reconfigure the space at a later date after the floor coating is installed? And I'll tell you an example of doing that. What if you had a commercial kitchen that wanted to install one of these floor coatings but couldn't remove the equipment out of the way? They can't remove the equipment. They've got like a safety inspection, so they got to coat the floor. And maybe at a later date, they're going to move that equipment and you're going to patch in those areas. If we know that in advance, we're going to recommend a coating system that is quick cure so that those patches can give you quick turnaround time and that are more, let's say, less noticeable. The patches are very much less noticeable. What's your project schedule? We'll ask you that because most of these systems we'll talk about today take 3 to 5 days to install completely and return back over to use. There are exceptions to that rule. We have systems that can go in quickly, 1 to 2 days. We've got coatings that'll cure in 30 minutes to an hour. And so we can do multiple steps in one day. The trick is those cost more and they typically have a higher odor. But if you've got that requirement, let's talk through that and we can educate you and your client and we can, get you the better recommendation based on your schedule needs. So this is a crew right here. I hope you can see my mouse over this picture. They're on their hands and knees installing a floor coating system. And what we're trying to demonstrate here is this door's wide open, this building's open. I don't know if the windows are installed here, but we would like at use conditions when these floor coatings are installed. At use means the way that the building was intended to be at use. If the building was intended to have doors and windows and heat and air ventilation systems operating, then that's what you want when you install these coatings. And here's why. Concrete is like a sponge. Concrete absorbs moisture and it dispels moisture. So it allows moisture to come in and out of concrete. And as it does, and as concrete goes through temperature swings and thermal cycles, it moves. That's why you have expansion joints in concrete. So you really want to close up that building and turn those heating and ventilation, air conditioning systems on and stabilize that concrete. Get it all conditioned and stable so it's not doing anything, any movement. If you were to be forced to apply these coatings before those heat and air systems are operating, what'll happen is you'll get the floor nice and coated, and the day you flip that switch on that, especially that air conditioning system, that concrete is going to move rapidly, especially at the joints. And so you're probably going to see some cracks. So at use conditions, I really recommend you think hard about doing that. So moisture vapor emission is something we ask. We really want to know about this one, also known as MVE. And you want to know, okay, if you've got it, if you've got a concern about it, see this vinyl composite tile on the left of your screen? This is black glue that's supposed to hold the tile down, but it's coming up through the seams that connect these tiles together. And that's not good. Why is that glue coming up? Most likely because there's moisture underneath of that concrete slab and it's pushing that glue up through these seams. Since I've been in the business a long time, I can tell you 99% chance that's exactly what's going on here. So we offer an inspection service, and I'll brag about us a little bit. I'm a certified inspector, so I'm often called, or I'll recommend that you let me go look at the project before I even recommend you a system. Let me go out there and look at it. And if I see this glue, I'm going to tell you, you've got moisture. So what if you don't know? You just can't look, or it's a new building. It's not even built. We're just drawing the blueprints, writing the specs. How do we test for moisture? A couple of ways. We've got a calcium chloride test. That's where you're going to get a standard. It's going to tell you how to test. The other way would be a humidity probe test, where you drill into the concrete. And both will give you readings. Both have standards. Both, you can put in your specifications. And if the readings are above the supplier or the manufacturer's limitations, then you have to do something about that moisture. And what can you do if the moisture readings are high? First thing you can do is you can eliminate the water source. What if you can't? What if you don't know where the water is coming from? Then you have to put down like a vapor barrier or retardant primer. And you didn't specify that more than likely because you didn't know you were going to have high readings. So guess what? It's going to be a change order. And everybody's going to have to scratch their heads and agree. So that's going to stop the installation process. The last thing you can do, especially if you know that you've got moisture concerns, is you could just simply recommend breathable floor finishes to start with. A lot of folks don't know about breathable floor finishes. They've been out about 15 plus years, and that's where they allow moisture vapor, not liquid, only the vapor, especially if it's under the slab and driving up through the slab. It allows the vapor to pass through it. See this? It passes through this coating system, not like in the red, the old school, traditional, non-breathable coatings. The vapor would pass and it would blister and peel off the red coating there. The blue coating on the right, you can see this actually passes through. Now, these can be applied to green concrete, meaning brand new, freshly poured. You don't have to wait. They can be applied underneath, non-permeable, and that can be your retardant, okay? You don't even have to take moisture vapor readings. Okay, if you do specify these breathable systems, you don't even have to take moisture readings. They're going to save you material and labor costs, and it's going to prevent a lot of problems. So rule of thumb is these breathable coatings, they cost about 15% more on the material and zero upcharge on the labor. They install just like the traditional systems. Used to be a lot of people thought they were lower performance, and that's not the case today. I'll tell you a project I did about 6 or 8 years ago for the Boeing jet manufacturing company. They built a facility where they manufacture jets outside of Charleston, South Carolina. And they were spilling or concerned that there could potentially be a spill of jet fuel. And that's called sky draw. So they built big trenches underneath the jets. They were near the ocean, low elevation. These trenches were below grade, so they knew they wanted breathable, but they also needed chemical resistance against sky draw, that jet fuel. And we recommended, and they selected and installed breathable, chemical resistant coatings throughout that entire project at Boeing. And today they still look great and they're still performing great. So these are great to know about. You can put decorative flake or quartz on top and make them pretty. So they don't have to be industrial type. You can do high-end commercial grade breathable coatings. So when you prepare the concrete, what you want to do is mechanically prep, okay? Look, see this machine? You want to use mechanical, not acid etch. If you muriatic acid etch concrete, then you're going to have to neutralize it, meaning you have to rinse off that concrete because you have changed the pH in the concrete. Where are you going to rinse all that? That's usually an issue. Where are you going to rinse all that acid? There's usually not a great plan laid out for that. And then you're going to have wet concrete and you got to coat it. So now you got to wait for it to dry out. So we highly recommend you mechanically prep the concrete. That's a floor grinder right there. And let's look at some other machines. This is a hand grinder. It's got a vacuum attached to it so that if he creates some dust, and it's going to, take that dust through the vacuum. But he's using this where he can't access with this big blast machine. Okay, this shoots a metallic bead into the concrete and actually removes about a 32nd of an inch. And so not much, but a little bit of that top layer of concrete. It takes that off. That's called the latent layer. That's actually the weak layer of the concrete. So always mechanically prep and remove that latent layer. So I've been asked the question many times, if the concrete's brand new, can't we just clean it? Can't we just pressure wash it and then coat it? And absolutely not. Zero. Don't do that. Because when you finish concrete and you vibrate it and then you trowel, you finish trowel it, power trowel especially, the cream rises to the top. That latent layer is what is the finish. That's that weak layer. And that's not what you want to bond to. You want to blast that off so that the penetrating resinous primers can soak into and penetrate into that concrete. So blast that weak layer off. Another question I'm often asked is, do you want a smooth or a broom finish on the concrete to bond to? A lot of people assume you want a broom finish because it leaves those nice ridges, that rough texture. And that's exactly what you don't want because those ridges are really weak. You could take a pocket knife and scratch those off. That would be another example of latent weak layer. So what will happen is the installation crew has to come in and grind those ridges from that broom finish off, and then they still have to blast. Now they have to do double surface prep, and they may complain and even ask for more money because it's not standard prep. But just a couple rules of thumb there about always mechanical prep. So how rough does the concrete needs to be? That's spelled out in this chart right here. And really, it depends on how thick the coating system is. The thinner the coating system, the less rough you want the concrete. But as you move up to thicker systems like epoxy terrazzo, which is normally about a 1/4 of an inch, as you can see in the bottom of this chart, you want the concrete rougher. So concrete surface profile is designated right here, CSP. Number 1 is the least rough, and number 10 is the most rough. And I love that in the bottom left of your screen, you've got some rubber comparators. These are 3 inches wide by 6 inches long. And they're just the comparators of the concrete surface profiles 1 through 10. If you're someone that goes out to job sites, especially if you've got to go look at a failure or an issue with a residence floor, and you had a set of these only cost $100. You could reach out to me or Todd and we could tell you where to get them, and we'll show you our email addresses later, and it's in the chat box. These are about $100. You could lay this on the concrete and you would know what the surface profile should have been, and you can put this comparator and find out if you met the surface profile or not, if the applicator did. You can put this chart into your specification and you'll be golden, okay? This chart, if you don't have it, the ICRI in the top right, that stands for International Concrete Repair Institute. You can Google them and you'll find that chart, and it's a wonderful chart to put in your specs. And that's for any concrete that you paint, whether it's on the interior, exterior, vertical, horizontal. It's applicable for all concrete that is going to be coated. So let's talk about details. You know, what kind of terminations do you want? And what kind of cove base? See this cove, this lip? There's actually no lip there. That's a smooth transition to the wall. There's other cove bases out there like bump cove bases. You know, you've got this one in the bottom right that's a 45-degree angle, okay? And this bump cove, you know what I like about this? I forget to tell people this a lot. This was actually a quarry tile floor that had a quarry tile cove base that we just simply went right up over top of, okay? We bonded to the quarry tile on the floor and the quarry tile on the cove base. So there's all kinds of details out there that I encourage you to get in your drawings and spell out exactly what you want. This is another little detail of that tile, existing tile will go up on top of. What about cracks in concrete that were unintentional? They were accidental cracks that could potentially telegraph through your nice resinous floor, especially what if it's a nice expensive terrazzo floor? You don't want it to crack. So we have what we call flexible crack membrane. You mix it together, parts A and B, and you pour it out, and it cures like liquid rubber. This stuff is about $3 to $5 per square foot installed, and it gives you basically protection. It minimizes your risk against your finished floor cracking, because as you can see right here, this membrane, okay, it absorbs all the movement. So the crack comes up through the concrete, there's movement in the concrete. This membrane, liquid rubber crack membrane, it absorbs it. And now if you had like a nice terrazzo on top of that, hopefully that wouldn't crack. The movement wouldn't exceed the limitations of the suppression membrane. And of course, the crack suppression membrane has some limitations. This is the application of that crack membrane. What I'd like to point out here is this serves two purposes. Not only as crack membrane, it could also be used as waterproofing membrane. Let's say you had an area upstairs like a commercial kitchen or shower, or even a mechanical room that saw potential leaks or washdowns, and you didn't want those leaks to go to occupied space below. You could paint the concrete first initially with this crack or waterproof membrane for $3 to $5 per square foot, and then go on top with whatever finished flooring you wanted. So this serves as both your crack or your waterproofing membrane. And this is a picture of the Ohio State University. Beautiful terrazzo job. These men right here, I believe they're like from head to like this part here, you're probably talking 15 feet, because this is all this picture is taken at a second-story mezzanine looking down. So this is actually a very large area, but they spent a lot of money and a lot of time with all these details and patterns. And because of that, it drove up the cost, and they wanted this to last the life of the building. So they went ahead and put the crack suppression membrane into the budget, into the specification. And that's what you're going to want to do for your nice terrazzo projects. Make sure you specify that crack membrane. Okay, so wall coatings. We can apply these coatings on the floor and on the wall. These polymeric materials can be used to protect the wall, make that wall seamless so it's more sanitary. We can also restore walls, bring them back to like a smooth surface. If we need to beef up the thickness of the wall coating, we can put fiberglass mat into that coating. We could also put chopped powdered strand fiberglass into the paint and roller apply it. Or, you know what we could do? We could even put that flexible coating system onto the wall. And that might give you good impact resistance, especially if you had two dissimilar wall substrates abutting. What if you had a gypboard wall abutting like a block wall, and you were concerned of movement along that transition? Or what if you had really hot washdowns where you thought that wall was going to expand and contract rapidly? These flexible coatings would be a good solution for that. And this is a picture of a CMU, a concrete masonry unit, block wall, where the mortar joints are visible, that you can notice these joints. And this was acceptable to the owner. But if it hadn't been acceptable, we do have a joint filler compound material where we could strike those flush, but that adds cost. So just to put your thinner, like 10 to 12 mil systems on these walls, you're looking at about $3 per square foot. You can get up to 100 mils, which there's 1,000 mils in an inch. So you're talking about 1/10 of an inch. Once you start pushing up in thicker systems on the wall, especially putting the fiberglass mat, you can get up to around $10 per square foot installed cost. To strike those mortar joints, you're adding at least $1 or $2 per square foot. So, understand what your client wants and then deliver and educate them on what, how much they can get for their budget. This is a picture of a correctional facility. So this is like a prison, and these are, this is a bathroom, and they have to use cement block or some other type panel wall. They can't use quarry or ceramic tile because that can be used as a weapon or shank. So we often use and see these wall systems in correctional facilities. Okay, and so let's talk about the coatings for the floors, the slurries, and the mortars. Those are the three types I kind of want to dive into. The coating being the cheapest, the thinnest, and the least life cycle. Usually a coating is no more than about 30 mils. There's 1,000 mils in an inch. I mentioned that earlier. You typically are going to just paint a coating, just roll it right onto the floor, like a primer, a middle or an intermediate coat, and then a top coat. This is usually the simplest, quickest. Like I said, this is the $3 stuff. It's going to be cheap. It's going to be quick. You and I could probably do this no problem. Mix it up in a bucket, dip and roll. And coatings are simple. They're going to be around forever. I mean, we're always going to see coatings. Here's the thing about them. I want to show you some limitations. The middle right here says they won't hide surface imperfections. That's probably the most important thing to know about just a simple thin coating. It won't hide surface imperfections. So let me tell you how that gets me into trouble sometimes, is I'll have a specifier tell me the client only has $3 a square foot, or that's the top. That's as much as they could possibly afford. And I know for sure that's only going to buy them a thin mill coating system. But then I find out that it's an old building and the concrete looks really poor. It's all chipped and damaged and got divots in it. So that's when now we have to educate that client and that owner and let them know that for $3, they're going to basically get a coating that's going to mirror through, telegraph all those chips and divots. So you're going to have to go patch all that with something, and that's going to add cost, okay? So when you enter with just a coating, you really want to be applying those on bare, good, new concrete, and educate the owner that you're going to get a few years out of them life cycle. You can develop wear traffic patterns through coatings quicker. If you drop impact, you're gonna probably chip the concrete underneath that coating. Okay, you don't have a whole lot of thickness to protect that concrete. If you want a thicker, longer life cycle system, you could consider a self-leveling, like a slurry. Okay, slurries are thicker. They're usually going to be around 1/8 of an inch. You're usually going to see these clock in at around $4 to $8. And maybe a little more per square foot installed. And these are going to move you into more of the 15-year life cycle. Okay, so you're going to get more life cycle because they're going to cost a little more and be a little thicker, give you a little more performance characteristics. Here's a floor squeegee, okay, just like a window squeegee, but it's on a pole, and he's dragging the material and spreading it. This gentleman on the left, he's broadcasting some kind of aggregate into that slurry, and that's not only to build texture, it's also to build thickness. So it makes the system thicker. Now, tomorrow, after that's nice and dry, they could come in and repeat that whole process. It takes a little more skill. Okay, so it's going to be going to need to be a little more selective on your applicator, and hopefully they've got the qualifications to put one of these in. And what if you want a decorative flake, as you see in this picture here? This is like a decorative vinyl flake. We also call these decorative broadcast flake floors, or decorative paint chip floors. Okay, so you can broadcast that in to that slurry, let it dry, come back tomorrow or several hours later, and seal it with clear sealers that are chemical resistant. They don't require waxing. They're stain resistant, chemical, they give you a lot of advantages here. You could also do decorative quartz, which is not paint flake or chip. It's silica sand, quartz silica sand with multiple colors. If you ever heard of a decorative broadcast quartz floor, That's what we would be talking about. Here is a decorative metallic floor. It's thick. It's like a slurry, but we take metallic powdered metallic pigments, and we disperse them into the fluid or the resin. And as they disperse onto the surface, they make these random patterns. This is a really cool one to know about. It's been out only maybe less than 10 years that I've seen it. And what I really like about it, gives you a really aesthetic, pleasing floor. It's kind of that wow look. And it's between $4 and $8 a square foot installed. So for clients that can't afford terrazzo but want that kind of beautiful look, they can look at one of these floors. And yes, if no one's noticed, that is tennis balls on the bottom of these bar stools. That owner had it in his head that he really wanted to protect that floor, so he chose to do that. Here's the cool thing. This floor right here is 2.5 years old. And my colleagues were telling me the other day, they visited this facility in January, and the floor looked as good as the day it was installed. So these are pretty heavy duty floors, these decorative metallics. We actually did include a powdered aluminum oxide into this top coat. That's that abrasion resistant additive that I mentioned early in the presentation to give them more protection against scratching. So here's a decorative paint chip broadcast floor in healthcare I mentioned to you. And once you start adding this this chip or this quartz, you're going to move into like $6 or $8 square foot range. So it's not terribly expensive, and you're going to get about 15 years life cycle. And once it does need refreshing, you just simply sand it, reapply maybe in one broadcast and one seal coat, you're done. You typically don't have to do the entire slurry again, and you don't have to blast that concrete and get it all prepped again, which is usually over $1 per square foot just to do the prep on concrete. So you've saved that money as well. So Slurry Cons, like, what's bad about them? Not necessarily bad, but they take a little more skill. You know, they're not great for sloped surfaces because they do seek their own level. So let's talk about what is the best, thickest, longest life cycle system. These are mortars, and that's exactly what they're power troweling right here. This is a resinous mortar. We take silica sand and mix with the resin and the hardener in the bucket, and we apply it by power trowel, and we can fill in chips and divots in the concrete. The mortars are going to give you a long life cycle, usually over 25 years. And epoxy terrazzo is actually in the family of mortars. It's been documented that epoxy terrazzo should give you about a 60-year life cycle. These mortars are usually about 1/4 of an inch or thicker, okay? And so as you can see right here, this should be your concrete that I'm putting my mouse over on the left picture, and then you do a primer in your mortar, okay? And you could just simply put solid color seal coats, and that's going to clock in. Mortars usually start at around $6 to $8 per square foot installed. And then if you had an aesthetic pleasing area, front of house area, you could decoratively broadcast that flake or quartz on top of that mortar, and that's going to push you up into the $10 or $12 per square foot range to add that decorative look on top of that mortar. What I really like about these is you can provide pitch to the drain. You see where I've got that in the middle of your screen? And that comes in handy if you've got a commercial kitchen renovation and they said they had ponding water, they had standing water, so they want to properly pitch to the drain. These mortars here that are on the screen, they cure overnight. The following day, they achieve up to 10 and 15,000 PSI, which normal concrete is about 3,500 PSI, maybe 5,000 if you're using high strength concrete. So this stuff is double, if not triple, the strength of concrete overnight, okay? It's got chemical resistance in the mortar. It's gonna give you, like I said, real long life cycle. It's gonna mask a lot of imperfections if you've got a bad damaged slab. And you're going to see these installed in heavy abusive areas like manufacturing and traffic aisles, loading docks. And so let's jump on into epoxy terrazzo. This is where you take that mortar and you mix marble aggregate in with the epoxy resins. First, you lay your divider strips to separate your colors and your patterns. An epoxy terrazzo, once it's laid, it looks all one color because the marble is covered up by the epoxy resin. So you're not actually going to see the marble yet. You have to let that cure, and then the following day, once it's nice and hard, you come back in and you take this grinder and you start grinding on that epoxy terrazzo to expose those marble aggregates and to start the polishing process that gives you the gloss on epoxy terrazzo. So once you start that grinding process, you expose little pinholes around those marble aggregates. And to fill those pinholes, you start grouting in the terrazzo. You're applying that 2-part epoxy grout, pushing it into those pinholes, see them pushing it and putting just a very small amount. And then you continue the grinding process. And once you have a finished product, it looks like this. This is the McCormick Place Convention Center in Chicago. That project is pretty old. I want to say maybe 30, 40 years old. It was one of the largest at that time of an epoxy terrazzo project. And this is a very nice demonstration of an exotic epoxy terrazzo floor with lots of different inlays, lots of different patterns. Epoxy terrazzo, one color, one pattern, 5,000 square feet, wide open, is probably going to budget price in $15 to $20 per square foot installed. As you add patterns, as you add different colors, and especially if you get into exotic aggregates, okay, once you move up in like mother of pearl or glass chips, you're going to increase your cost. So floor like this, you could be in the $100+ per square foot range. Some more new technology, ergonomic. This is where we have comfort floor, okay? This is soft to stand on resinous flooring. So remember that liquid crack-proof membrane I showed you? We're taking that material and adding rubber aggregates. So that looks like rubber terrazzo. And that's pretty much what it is. And we found this to be very popular in healthcare, especially operating suites where you have medical teams performing surgeries that take many hours, and these medical teams are standing on their feet for long periods of time. These are also seamless. So unlike your sheet goods that have seam points where you could potentially capture and collect dirt, and then you can get into some sticky situations with bacteria. These are seamless. There are no seams. You can roll these right up the wall for your Cove Base, and they have the ability to incorporate antimicrobial additives. And so these are also stain resistant. For those of you that have ever experienced betadine and how it stains in the operating suites, we've developed betadine resistant flooring. So it's pretty good to know about. This is another good picture that allows me to also talk about another benefit of these soft comfort floors. They are sound dampening. They reduce the decibels of sound in the area. So not only are they comfortable to stand on, they'll actually reduce the sound, and that could be important in an area where you have a lot of foot traffic, maybe a big Coliseum corridor, or maybe a big cafeteria where you've got a lot of noise. So these clock in at a cost of about $12 to $15 per square foot, and that's for the liquid rubber with like a decorative broadcast flake on top. If you want to do the liquid rubber terrazzo type floor, that's going to cost you about $25 per square foot installed. And these have only been out maybe 10 or 15, probably about 15 years. They're still holding up, the first ones that were ever installed. So we don't truly know the life cycle of these yet. The ones that were installed 15 years ago still look great. I've seen several of the projects. So urethane cement, we're coming down the final stretch. This is where we take 2-part resinous material and we add concrete. And it is a really cool system because it's fast. This stuff cures in about 4 hours. It can go on green concrete and it's very thermal shock resistant. And that's important in commercial kitchens. So this is going to be your commercial kitchen floor, urethane cement, okay? That's definitely what you want to put in all your kitchens. It expands and contracts at almost the identical rate as concrete, which means when it's thermal shocked, it's not going to crack because epoxy doesn't move at the same rate as concrete. This is different than epoxy. This is a urethane chemistry. This is what you want to use in your commercial kitchens. I know I've said that a few times, but I want to stress that if you're doing a kitchen and you're calling it epoxy, that's okay, but just as long as it's not epoxy. It needs to be urethane concrete. These are about $6 to $10 per square foot installed, and I like them a lot because they're thermal shock resistant. It's what all the food and beverage plants use, and they bond really nice to quarry tile. And you may have commercial kitchens out there that want to renovate. They don't have the time to demo and tear out all that tile, nor do they have the money. So they can come in and clean that tile, degrease it, grind the glaze off the tile, and we have special design primers to bond to that tile and then put in these urethane cement systems, run the Cove Base right on top of the existing quarry tile Cove Base. In as little as 2 or 3 days max, you could return that commercial kitchen back to service. Turnkey, done. And so I think that's going to about wrap it up. I said those systems right there are between $6 and $10 installed. If you broadcast a decorative flake and decorative quartz on top of those urethane cements, and they're usually 1/4 inch systems, and you're going to push up into probably $10 to $12 range. Those life cycles are 25 plus years, typically what we're going to see. So we've talked about, how to select a system, how to prepare the concrete, installation strategies, you want at use conditions, and we talked a little bit about new technologies. And so that's about going to do it for me. I'm going to turn the presentation back over. Can I stop sharing my screen because I'm about done here? And this time I know that we're going to be able to take questions. So I'm going to push the stop sharing.
All right, sounds good. And I'll just get us back for a moment while we wait on any questions coming in. Just take a moment to let everyone know about a couple of the other continuing education opportunities that we have coming up. May 26th, Construction Specialties is presenting an HSW. June 2nd, we have another one from Schluter. We have a presentation on June 10th from Hahn, and June 16th, we have another HSW coming up again from Construction Specialties. And again, let's see if we have any questions coming in. Not at the moment. So just so you know, we also have lots of ways to stay in touch with the AIA. Please feel free to take a look at our LinkedIn group and sign up for that, as well as our COVID resources page on our website. And again, you can sign up for any of those events that I just listed through our website. And feel free to contact either Lauren or I through our emails listed below. All right, do we have any final questions to close this out? We'll give folks just another moment in case they come up with something. And in the meantime, Todd and Philip, thank you so much. Philip, I don't know if you want to share your screen again or put in the comments what your contact information is in case folks want to reach out.
Okay, let me see. You see that?
Let's see.
Yeah, got it.
Great, yes.
I don't know that we said this, but this is IDCEC accredited. You could reach out to me or Todd in the event that there is anyone online on this program that needs IDCEC credit.
Oh, it looks like, so Joseph says, great job, very informative. And then we do have a question here in the chat from Ross. For resinous wall coatings, I'm often getting requests in high-end residential to have a continuous wall finish from a bathroom wall into a shower. Todd Elector marble plaster seems an option, but curious if there is a paint or coating solution for this goal.
Yeah, it's not a great solution going on top of water resistant board in a shower for residence or even commercial. Once you do that gyp board in that real high humidity area, we've tried all kinds of wall coatings. We've tried the thin, we've put the matte, we've done the flexible, and those gyp board in wet environments with that humidity, it just moves too much. As I'd like to say we've got a great solution, I don't like to see it. If you're going to do it, and you can put a cement board or a block wall, which I doubt you can do in residential, that's what we want to see. So I don't know if you can do cement board in those residences as a substrate, then we absolutely could do a wall system over it. But I would never want to do gyp board anymore as a substrate.
All right, and if folks end up having other questions, they can reach out to either you or Todd, I assume?
Absolutely.
Yeah, please don't hesitate. If there's any need for a resinous floor wall system, let us know. And again, we'll kind of go through some of the conditions that would be present to make sure we get the right system.
Excellent. Excellent. All right, well, Sherwin Williams, thank you so much for joining us. And to all of our attendees, thanks for showing up today. And everyone stay safe, and we'll talk to you soon.